Right. If I pressed the right button, I think we should be live. Let me quickly verify on the LinkedIn side. Wait for the boss to start. View on LinkedIn. Hi everyone. By the way, just 1 second until I make sure that everything is up and running. It looks good. I think we're live. Cool.
Nice.
Then I'll start my little introduction in a second. I already have my slides open, so we are all good here. Okay, it's all good. Cool. So let's jump into it. Welcome everyone. Thank you for joining us today. I'm super excited to talk about and walk you through how to build right time data pipelines and what right time actually means for modern data teams. I think we're live on both on LinkedIn and YouTube. So if you have any questions throughout the presentation, please write them down in the comment section, and we'll dedicate some time at the end after the demo to go over them and answer each. So my name is Dani. I am head of marketing at Estuary, and today I am here with Zulf, our head of sales engineering. He brings a lot of experience in high volume data replication from Oracle Golden Gate and HVR, and he's going to give a live demonstration about right time data pipelines using Estuary. We are going to, let me just go to the next slide. Yeah, so this is today's agenda. We are going to give a quick overview of Estuary, the company, who we are, and why we actually exist. And after that, we are going to talk about the platform itself, how we are helping data teams move data across systems and move away from brittle ad hoc data pipelines. After like 5 to 8 minutes of slides, we'll jump into the super interesting part, the live demo, and where you can see right time data pipelines working in action. So I would like to start with the problem that modern data teams face. So if you work in a data team or work closely with data, this picture probably looks familiar. You probably have a lot of CDC systems, batch processors, cron jobs, warehouse transformations, even Python scripts, stream processors, and many other things that seemingly all serve the same purpose, which is moving data from point A to point B, optionally transforming it on the way. These disconnected systems have different SLAs, different retry patterns, and almost always a lot of tribal knowledge behind them, which is very hard to unravel. So as you probably have experienced, each of these systems is a moving part. They individually have to be deployed, monitored, maintained, secured, and scaled, of course. Every time a schema changes or any of the business requirements change on the other end, a lot of these pipelines break, and that's very painful. To combat this, organizations end up with something that in most cases is super complex, very expensive, and most critically of all, fragile. Batch systems usually can't deliver fresh enough data. Stream processors are notoriously difficult to operate and expensive, and change data capture is unreliable. So this is kind of like the status quo currently, and it is what Estuary set out to solve. So to talk a little bit about Estuary, it was built to unify and simplify the entire data integration layer. So with Estuary, you get one system that handles CDC, streaming, and batch data, and it does it so reliably and at scale. So instead of managing dozens of different ETL jobs, you can actually define what data should move and how often, and Estuary handles the rest for you. So we give you, or the platform gives you, continuous change data capture, exactly once delivery semantics, schema evolution built into the platform, and of course, there's a huge library of connectors that covers databases, SaaS tools, message queues, analytical stores. So all of the common parts of a modern data stack. So this whole thing operates, of course, on enterprise scale. We handle massive throughput of data that is increasing day by day, and do so at for specific connectors in less than 100 milliseconds of replication time. So Estuary itself is a company that was founded around 6 years ago, I think. To give a little bit of a backstory, the platform itself is built on top of Gazette, which is the foundational framework that powers both the streaming and the unified batch data integration pipelines. And over the years, the focus has always been one core challenge, which is helping organizations capture and make use of their data as it changes. So today, Estuary is used for real-time analytics, operational data syncing, AI feature pipelines, and large-scale system migrations as well. So you are probably curious about right-time data and what it actually means. And I wanted to talk about this for a second before I hand it over to Zulf to talk a bit more about the technical parts. So right time is not just about being fast. It's about delivering data at the cadence your organization, your business actually needs it. So in some cases, this can be real-time streaming, sub-second, or even lower latency freshness for use cases like personalization or anomaly detection or fraud detection. But in other cases, this means micro-batch delivery every few minutes or hours or even days for cost efficiency. In almost all cases, organizations need both of these. They need a blend of real-time and batch data movement across all of the systems that they use. So to us, right-time data means customers don't have to choose between heavy streaming infrastructure and slow legacy tools. This trade-off is successfully abstracted away, and instead Estuary lets you deliver the right data at the right time to the right place, and all this completely automatically. So that is the foundation for everything that we look at in the demo, and everything that defines the company and the product itself. And if you have any questions about right-time data, I'll be happy to answer in the chat or after the demo. So please write them down. And with that said, I'll hand it over to Zulf, who will talk a little bit more about the technical architecture of the platform and show the demo, show the whole platform in live as well.
Thank you, Dani. So good morning, good afternoon, good evening, depending on where you guys are calling from. It's a pleasure to walk you through a guided tour of Estuary today. So as Dani mentioned, I'll take the lead moving forward and give you a bit more deeper dive into the architecture and also the demo. So if we can move on to the next slide, please, Dani. Great, next slide. Yep. So let's take a moment and describe the architecture for Estuary. There's some unique components in here that I really love about the technology, which I want to share with you guys. So first of all, it's a cloud platform. We can deploy on AWS, Google, Azure. We have different deployment methods, which we'll look at in the next slide. But first of all, I just want to focus on three main components that we have within our infrastructure. The first component is our capture component. Dani mentioned that we have a plethora of different technologies that we support. And again, we'll have a look at some of these technologies in a later slide. But the sole purpose of the capture is to acquire that data from your source. And within that single platform, we can support CDC, we can support batch, we can support streaming. It depends what the technology is. With certain technologies, we'll have options for both, near real time as well as batch. So the purpose of the capture is to acquire that data from your source. Now, once that data has been ingested, captured, we do persist that onto disk. So where you see the drive or the collections in the middle, that's where data is persisted. And we always recommend, as part of best practices, to always create your own storage. So as part of Estuary's offering, we have our storage, but by default, not by default, but best practices, we encourage you to set up your own storage. So it's based on your environment. You can put some security policies around that, but more importantly, retention policies. And I'll explain why that's important as well. So once data is persisted onto disk, onto cloud storage, into a live data lake, so to speak, it's now decoupled. So these components, the materialize, the capture, they're not dependent on each other. Why is that important? So say, for example, you're streaming data downstream to Snowflake. Suddenly Snowflake's not available. Your materialization job can't apply transactions. That doesn't mean that your capture component stops as well. So it's not a one-to-one mapping of data pipelines. Because it's a decoupled architecture, your capture still continues to process transactions in near real time from source and persist that onto disk. And each component will have its own checkpoint mechanism. So the materialization job will have a checkpoint where it's reading from within the collections and where it wrote to within Snowflake. Likewise, the capture will have its own checkpoint mechanisms from source read to writes into the collection itself. And Dani mentioned a key word, only one semantic. So we also guarantee no duplication of data because we capture once, we deliver once as well. So having that checkpoint in place ensures there's no duplication, but more importantly, no manual intervention. Once Snowflake gets up and running, we take over automatically from where we left off. There's no manual intervention required to tell Estuary where to begin. Secondly, what does collections allow you to do? Now, with a long enough retention policy, data is there in your live data lake. So if you have a request where you need to spin up new environments, or say, for example, you just need to rebuild something downstream, maybe a table or so, it means as long as we've got a long enough retention period in the collections, you don't have to go back to your source to replay those transactions or to load another destination. So the ethos here is you capture that data once, but you use multiple times downstreams for different use cases. Capture once, use many. Next slide, please, Dani. Now, we spoke about deployment options. So we have our managed service, which everyone loves, the hassle-free, we don't have to do anything. So we have that public offering. However, for certain sectors like healthcare, like finance, there's more regulation around data protection, maybe data processing. So if you require more specific, dedicated infrastructure that belongs to you and, data processing needs to happen in a certain place, private and bring your own cloud or BYOC gives you those options where you can spin up a dedicated plane based on the cloud vendor of choice and region of choice as well. The difference between private and bring your own cloud, it's who spins up the VPC. With private, Estuary does that for you on your behalf and gives you access. Whereas bring your own cloud, so you using your own resources, your own infrastructure, and you're telling Estuary, hey, I've got this. Can you deploy your code within our framework and still manage this for us? So the great thing about all these options, it's still a managed service. It's just where you want the data processed and who spins up that VPC. Next slide, please, Dani. And we mentioned connectors. So we have over 200 different plus connectors that we maintain ourselves in-house. So we're not reliant on third-party people connecting, creating these connectors. We develop it ourselves. We maintain it. If there's new versions, changes, we always maintain it and make sure it's always up to date. So there's no, again, manual intervention required from our end users itself. And we've got connectors that range from different categories, from critical databases like Oracle, SQL Server, Postgres, MySQL, to SaaS applications like Salesforce, Greenhouse. Again, 200. We've got a whole list on our website. So I encourage you to look at that. We also have documentation on our website based on all of these connectors. So what's required to stand up a certain connector for source or as a destination. Next slide, please, Dani. And we're coming close to demo time. So what we want to show you today is a real life scenario of Estuary. And what we're going to be doing is taking transactions from a Postgres source that we have. So there'll be a basic a demo schema in there with some single table in this case with some sample data. What we're going to do first of all is we're going to replicate that into Snowflake in near real time. And again, I mentioned the power of Estuary being able to take data once and deliver multiple times. So we're going to actually spin up an iceberg table downstream as well and have data populated in there. So fingers crossed, it's a live demo. Fingers crossed all works. So stop sharing. I'm just going to share my screen now. Almost clicked on Leave Studio. Not a good one. Let's go share screen. Okay, let's share the entire screen. And hopefully what you'll see, and Dani, you can just give me a quick shout out, making sure I'm sharing my screen. You should be able to see PG admin.
Yes, it looks good.
Great. Right, so all you guys can see it. So I just wanted to show you the infrastructure that I'll be using just to make sure that you can see that there's some data there. So this is my Postgres instance. Like I said, I've got a sample table here called movies with some basic data in there about some movie collection that's historic, old, haven't updated it in years. But we're going to be taking this data and we're going to be populating that downstream. So downstream, what we'll have is, and if I just move there, so what we'll have is Snowflake. Now, I wanted to show you this because Snowflake, I haven't actually had to pre-prepare anything. And what I wanted to illustrate here is that Estuary will do all the hard work for you. So once we've identified what data we want to move across, I want to get Estuary to do all the hard work and do the lift and shift to say, go ahead and build the schema, build the tables, and then move the data for me. So you can see here that this movies table does not exist anymore. Here's a list of my demo DB that I'll be using and a list of schemas that I have in there. So I'm going to actually create a specific schema for this webinar and get Estuary to do that for me. Likewise, while we're here, we're just going to show you the infrastructure for S3 as well for the iceberg tables. So I'm going to be using our connector that supports AWS 3 for iceberg tables. So I've got something in here in terms of my S3 bucket in here, but we're going to give it specific names. Again, I'm going to give it a naming convention that's specific to this webinar. So nothing in there is created. Likewise, in Glue, in my catalog, I've got something in there, but again, we're going to give this a different naming convention. So again, it's about Estuary doing all the hard work for me and creating this in advance. Well, not in advance, but as we create the data pipelines itself. So now, to the main event, let's move on to Estuary. So here, as soon as you log on, you'll be welcomed within a welcome page. In here, you can, again, get quick info around how much data or how many processes you have active. Again, if there's any alerts, you can get it from a single pane here. So this is like kind of your central console to monitor everything from a holistic point of view. Now, likewise, I mentioned the three main components in our architecture. That's how we've split the sidebar in terms of navigation. So we've got our sources, we've got our collections, we've got our destinations, and we also have admin here. So I mentioned earlier on when we talked about the architecture slide and we talked about storage. From here, you can create new users, give them access to Estuary. So whoever goes ahead and logs on to Estuary for the first time will have that admin privilege to start creating new users and give them certain accesses. In settings, again, cloud storage. So I'm using the default public plane. So from a data process point of view, here's what I have access to in terms of data planes. I don't have anything set up as private. Again, that's private. Bring your own cloud. We'll have this listed in here. And again, configure storage. So here you can put your own storage bucket. So we support both AWS, Azure, and Google Cloud. Now let's go back to sources. So here we're going to show you the whole process. How do we take that data from Postgres and how do we start populating that downstream to whatever technology we want? So as soon as we click on New Capture, we have a list of all different connectors in here. Now I can see Postgres from the corner of my eye, but if there's a certain connector that we're interested in, we just need to type it in and we get a whole list. So you can see here that we've got different flavors of Postgres that we do support. I mentioned again, with certain connectors, you'll have options on how you want to move the data or when you want to move the data. As Dani emphasized, we're all about, the right time. And coming back to the right time, actually, while we're talking about this, you'll have use cases where you want real-time data movement or you want batch, but it may not be all or nothing. And what I mean by that is there's still advantages of perhaps capturing real-time data from source, but perhaps on the target, you may want to apply that as micro batches. An example of this could be Snowflake and Postgres, what we're doing right now. We want to capture in real time. Why? Because it alleviates the burden on the source when we're capturing live from the logs. If we're doing incremental batches from source, that means we're doing, heavy lifting and shifting from the source. And should, the time frame be longer, maybe every 1 hour, maybe once every day, that's a lot of load that goes on your source infrastructure. And the whole point about CDC or real time is that you alleviate that burden on the source. So capturing real time, but perhaps in Snowflake, we do incremental batches, maybe every 10 minutes, maybe every half an hour. So you can mix and match when you want to both acquire the data and apply the data itself. So in here, very quickly, we've got batch, we've got CDC, and we're going to go for real time. Now, the next couple of stages, Estuary is going to walk you through the whole process in terms of what is it that you want to do. So first of all, what we need to do is give this a naming convention. So Zulf demo is the tenant that I've created, the organization when you first sign up. So anything within that tenant is going to be classed as your work. So everything of mine that I create from this point will be classed under Zulf demo. So I need to give this a naming convention, and we'll call this webinar, for example. You can give it any naming convention you like. We're going to look at this in a little while about naming conventions. Now, I spoke about data plane. This is where data processing occurs. So in the public offering, we have a few options in here. I'm going to stick with EU West. I'm based out of the UK, so, that's my preference. The next couple of sections is about how do we connect to PostgreSQL. So I have Postgres on my laptop, so I need a tunneling mechanism to connect locally. So I'm going to put that server information in and the credentials to connect to Postgres. So we're going to actually use a Postgres user. However, the database was movies. So let's just change that. It's not going to be the default. Now, what we have here is an option called history mode. And let me explain what we do by default. So how we present the data downstream, there's a couple of or various tactics that you can use or strategies you can use. What we do by default is we capture the most final state of that transaction. So, whatever you have in your database, that's what we're going to replicate. Now, if we wanted to get history mode or all the transactions that have occurred, not just the final state, we click on history mode. So say you have a row with a certain primary key. If there was 5 updates to that same row or to that same primary key, what we do by default is we take that final state, the 5th update. We don't worry ourselves about all the other previous updates. And there's good reasons for this. As a cloud solution, it's less cost, less data movement. However, there are justifications downstream for certain applications where you might want to create a history table or an audit table. And for that, you may need all the transactions. So that's when you click on history mode. So I'm going to actually select this because we're going to do something downstream to show you a couple of different examples. And then we're just going to use the password to connect to that Postgres instance. Now, I've got some options in here, and each connector will have specific options that you can choose. So in here, all I really want to do is just give it a different slot name, and I'll call it test, and Estuary will do the automatic completion of the rest of this name convention. So publication, I'll stick with flow publication. I like that, so I'll stick with the defaults. Again, you have the option to change this yourself. And again, a few other options in here. So if you want to discover unpublished tables within your configuration, you can also do that. I'll also point you to network tunneling as well. So Estuary does support SSH forwarding with both private, bring your own cloud. We also support reverse SSH as well as private links as well. So I'm happy with that configuration. You can see how easy it was. You can see on the right-hand side as well, it has a link to our documentation. So I always encourage anyone that starts using a certain platform to read through the documentation because there are prerequisites that must be satisfied for certain platforms. Typically with databases, you have to do things in the back end in order to support CDC. And our documentation, you can follow this as you go through the configuration. So I'm just going to go ahead, quickly click on next. get things rolling. Hopefully the next stage, Estuary will confirm this for me, and we can tell Estuary what exactly do we want to replicate from source to target. So here it's identified that we've got a single table called movies based on the privileges that I've given this user. And that's another best practice recommendation that we always say for CDC users is you create a dedicated user for replication and assign the necessary privileges to access what tables you want to replicate. But also want to point your attention to schema evolution, because by default, we also replicate schema changes from source to target. So if anything changes with the schema, if there's new tables that are created, we want to create new collections from that. And we're going to have a look at collections in a little while as well. So by default, we do enable this. Optionally, you can have this disabled. I can also look at backfill mode. So data that exists within my tables, how do I handle that as well as ongoing replication? We have different strategies for bulk data movement. I'm going to stick with the default normal, but for example, if you just want to do only changes, we can also do that and skip the historical data side as well. All this is explained within our documentation. So again, I encourage you to go to estuary.dev or docs.estuary.dev, and you'll get more information. If there's, hundreds of tables, you can also give that backfill a priority for each table as well. So I'm happy with this configuration. Let's click on next. And we've got options here. We can test the configuration. For time purposes, I'm just going to go ahead, save and publish. This will also do a test, by the way, as well. So as we're now telling Estuary or to create the backend components, it will also make sure and verify that, do the privileges work out? Can we connect? And so what we're going to do is close, and you can see now we've shifted the pane. Now we're kind of in a monitoring view of this task. So naming convention, it's the tenant name, the task name we gave, which we called it webinar, and it's telling me it's source Postgres. That's the task name we have here. We also have some good tabs in here that I want to point to. So as well as the overview that will give me some high-level metrics around data movement, I've got a centralized pane for alerts for this task. I can see any task that's been fired off historically. I can also set alerts for data processing. So, if data hasn't been processed in X amount of time, go ahead and alert me. Alert or email notification can be set up in admin as well. Under settings, you'll see, setup of emails. I can look at the spec, the configuration files for this. History. So any change history that's occurred, that's going to be recorded. But more importantly, I can also view the real-time logs of what's happened in the back end. So we can see that there's things starting to happen. We're starting replication. So hopefully if I go back to source, I can get, again, a high level of overview of all my sources. And here I have also some good indication about data movement. So we can see we've read 10 rows from the source. And that should correlate when I actually drill in to this task as well. So I can see, data movement by volume of data or by number of rows as well. And I've got some useful information here about the connector, the status, the data plane it's running on, and what collections it's writing to. So we're capturing that movies table and we're persisting this into storage, and we've created a collection for that movies table. And again, paying close attention to the naming convention that we have here. The tenant name, the task name that's come from the source, the schema name, and the table name. And again, here we can see in terms of metrics about volume of data or number of rows that we've moved, we can identify that in terms of reading in. Writing out, you'll see it's 0, but that's going to soon change. But let's drill into this collection. Again, likewise, we've got some tabs here. We can see data movement, and we can also peer into the data itself as well. So we've got these 10 records, and we can see individual records as well. Like I said, when you put this within your own storage, you can put some security policies around that as well as retention policies. So providing you have a long enough retention, we can always replay from collections. So now that was phase 1, step 1. We've created a capture. It's gone ahead and created the collections. Now what we want to do is materialize this into Snowflake. So let's go ahead and create a new materialization job. So again, likewise, we can type it in. We've got Snowflake, and we support Snowflake as real-time connector. Like I said, we don't necessarily want to do that, and we'll show you how we do that in the configuration. But just of interest, we also support Snowflake as a source. So Naming convention wise, we'll stick with the same webinar again, so I can tie this in. Data plane that I want to process this data, again, we'll put it as EU, and then it's just the normal connection information into Snowflake itself. So the host, the database we want to replicate into, the schema name, right? So we've got 101 webinar that I'm going to call it, and that didn't exist, if you remember correctly, in here. So we're going to get Estuary to do this for us. Now the warehouse and the role. We've also got some options about timestamp, how we want to represent this downstream. But again, here we're going to do hard delete. So by default, we were capturing the latest view of the source, but I included history mode, which captures everything. Downstream, what we do by default is soft deletes. So if we see a delete transaction, by default, we will not delete that in Snowflake. What we'll do is we'll add additional metadata into that to say, here's the timestamp of this transaction, and this was the operation type. It was a delete. So it was marked for deletion, but we haven't physically deleted that record. I actually want to do this. I actually want to create a Snowflake target that mimics my source. So I want to see a delete operation performed as a delete downstream. So I'm going to use hard deletes. So Estuary supports both hard delete, soft deletes, and I'm going to show you as well how we can also do history tables, audit tables. So this is where we want to do slowly changing dimension type 2 kind of transactions. Every transaction that we see, we convert it to an insert downstream. So we'll show that in just a little while. So again, I just want to complete my configuration. And you can see with Snowflake, we support both password as well as JWT authentication. And I mentioned scheduling. So we're going to use the default, which is real time. But here I've got options now. How do I want to move that data downstream? Do I want to do it every 15 minutes, every 4 hours, etc.? I can put a threshold in there. Particular time zones that we're in. When do I want the apply process or materialization to start? When do I want it to finish? So I can put time restrictions in there as well. And what days do I want that to happen? So Monday to Friday. So you can be very granular of when you want to push that data. We can also trigger dbt jobs downstream, and this list will expand. We're always looking to expand this, and we're going to include new partners that we've just hooked up with. So you'll see more options as this goes on, and some advanced options. So here I actually want to exclude flow document. This is one of the columns that Estuary does require downstream for certain things, for certain use cases. But in my case, I'm not really interested. So I'm happy with that connection information. I'm going to go ahead and click next. And the next phase, again, what is it that we want to replicate across? Now, you remember schema name? We've already defined that. So on the source, it's the default public from Postgres. Downstream in Snowflake, we're changing that up. We've called a dedicated schema called 101 webinar. So this needs to change. Default naming convention. What mirror schema does is if I've got something on the source, I want that mirrored likewise downstream, like for like. So if it's public schema, go ahead and create the public schema. That's not what I want to do. I just want to create the table name and use the default schema that I've specified above. So that's going to change. And you can see there's different options that we have here in terms of how you want to represent the schema with the table names here. Now, very quickly, I'll mention this option, but I just want to go ahead very quickly for time constraints just to add what I want to replicate. So you can see we've captured, we have collections, and then now we just bind the collections to materialization. So which tables essentially do I want to move downstream? So we've got that webinar, public, movies. So I'm going to attach it to this replication. Let me just refresh that view. Now, what does this do? Link capture. So we talked about schema evolution, right? When things change or if new tables are introduced, we told Estuary, create new collections. Now, if new collections are created by default, it doesn't get added into your materialization job. You would have to manually do that. However, I can go ahead and link it to my capture job. So if anything changes from a schema perspective, new tables are added, what this option will do is it will link any new changes to your materialization job. So any new collections that have been created, it will automatically be added into your materialization job. Now, in my case, I'm not going to do that. It's going to be manual. It's a one-to-one, so I'm happy with that. Now, other options in here, delta updates. So if we tick this, what we tend to use downstream is Snowflake or Snowpipe streaming for Snowflake. What we also do is the slowly changing dimension type too. So if I want that capability downstream where I want to convert everything into inserts, this is the option we choose. Now, in my case, I'm not. I've got hard deletes, so I'm going to leave that blank. I also have options in terms of columns. What columns do I want to replicate? So I've got a list here of additional metadata. I can add them. I can exclude some things. Metadata op, for example, that was part of soft deletes. I don't want that as part of hard delete. So I can remove that. And I've got some advanced options in here. So right now, you won't see this because it's the first time. But once this task has been created, I can always go back and I can do backfills. So I don't necessarily have to go from source to do backfills. I can do backfills from the existing collections. And backfills is just reloading the target with existing data, right? So this is going to be the first time I do it. So it's automatically going to do a backfill, and then it's going to start doing the CDC, the changes. So we'll give this a couple of seconds for everything to spin up and start. Bear with me, I'm just going to have a quick sip of water, as I could feel my throat going a bit croaky, and close that. So now we're going to go ahead and create all the processes. Likewise, in the materialization job, I can see it's pending now. So things are starting to happen. I can look at alerts here, specs, history. Again, this is specific for this materialization job. Again, I can see the logs and what's happening in the back end. So we're opening up Snowflake. We're setting the checkpoints. Okay, we're starting the connector container. So we're doing things. We can see. We're acknowledging some stuff. Okay, finished, waiting for materialization, recovery. Okay, looks like we're going to start doing some data in a minute now. So I can go back into overview, and there we can see we've moved 10 records. So just very, very quickly before I move on to Snowflake, we can see we've captured 10. Now, under collections, I can see that we've read 10 and we've written out to 10. If I click on collections, I can see, right, this is my source connector that's dependent on this collection, and that's my materialization job that's dependent on this collection. So I can see the lineage of this data pipeline within collections. And in destinations, I can see, right, everything's running, and we've moved 10. So when I go into Snowflake, make sure we're on the right schema, and we go ahead, and now we can see we've loaded those 10 records as quick as that. So that's setting up one. What I want to show you, some real-time data movement, right? So very quickly, let's do this. We've got just a few more minutes. So I'm going to go ahead into Postgres. I'm just going to insert a new record in there. And let's go back to movies and make sure that's committed on the source first. So we can see Black Panther, the new record has been committed. Let's go straight into Snowflake. And let's bypass, and you can see that record is there now as well. So I bypassed Snowflake because it's real time. We wanted to show you that data moving straight away. So let's go and make sure, look at all the metrics. So from a source, we can see things have moved. So we've got 11 records in there. We've got 11 records. Likewise, destination as well has been updated. Okay, so that's showing you how we've set up a source, we've set up a target. We've done initial load. We've, moved one record. Okay, it's low, but it shows you the real-time movement. And we've got Estuary to do all the hard work and create everything downstream. Now, what I'm going to do just to finish off this demo is I'm going to create a new materialization job again. This time, I'm going to look at iceberg. And you can see the various flavors of iceberg that we support. I'm interested in Amazon S3. So I'm going to go ahead and materialize this job. Likewise, same principle. We're going to do this very quickly. Naming convention, data plane, how to connect to my iceberg. Right, so I just need the password for this. Copy, secret key. Right, the bucket, we've got Zulf demo, which exists there. You can see there's nothing in there. And prefix, we can add prefix. I'm not too concerned. Region, US East 1, I'm concerned with. And we're going to give it a different namespace. So here we're going to call it webinar data this time. Now, threshold, we talked about right-time data. We did real-time streaming for Snowflake. Here, I'm going to change this actually. Let's move this to 1 minute. So short bursts. And we're going to use Amazon Glue as our catalog. Again, we've got some advanced options in here. I'm not really interested in that. Let me just go ahead and make sure the connection's all good. Okay, great. So that's all. And likewise, we're just going to add what collections are specific for this materialization job, right? Just going to refresh that view. And again, likewise, we can link this to our source capture job if we wanted. And here we've got, again, what the table name is, alternative namespaces. So if you don't want to go through the default, and some tables may have their own specific namespaces, you can always put an alternative namespace in there. And we're just going to populate the columns, because we showed you in the last example that we removed some columns. Here, I may want to add additional metadata downstream. So here I can see, again, here's all my columns. Just for argument's sake, I've got this schema. Let's go ahead and add that in, and let's just go ahead and publish. So fingers crossed, again, I went through that very quick, and we'll get things moving along. So again, we just need to wait for Estuary to start spinning up things. Doesn't take too long. And I think I'm doing well for time. We've got a couple of minutes, and I think I should be done by then. Okay. So we're waiting for that to publish. So what you'll see here, again, when we looked at the architecture, it was about taking that data once and replicating that across two environments, right? So you can see here, I haven't created another capture job. So this is the benefit of Estuary. You capture that data once. So we've got PostgreSQL, we've got that data into collections. Now I've got a new use case where I want to stand up Iceberg. We can go ahead and collect that from our collections itself. So again, you can see one source running, go in sources. We have one collection based on the table name, so we only had the single table. But here, what you can see under destinations, we've got two live materialization jobs. Now, the Iceberg is pending right now because we're still creating the components, but you can see Snowflake is up and running. So let me just quickly go ahead, click on here, see what's happening within the logs. Okay, so we're doing something. Question materialization open. Okay. So let me go ahead, just to have a chance to see how long. Okay, so we've got that there. So this is my S3 bucket. I can see part of that webinar data, we've got movies. Let's go into Glue, and let's refresh this. There, so we can see webinar data. And let's actually view this using Athena. Let's go ahead, proceed. Okay, there's something here. Yep, let's remove this restriction in there. Right, let's rerun that. So we should see 11 records now. There we go. Right, so let's recap what we've done. We created a capture job to take transactions and existing data from Postgres. We've populated Snowflake downstream with that data. We've now added a second target in Iceberg S3.
I think your mic is not working, so.
Oh, has it stopped?
At least I can't hear you.
Can you hear me now?
Now, if you unmute yourself, maybe.
Ah, there we go. Was I muted for a long time?
Still nothing.
Still nothing.
But it's all right. No, I think now you're muted in the actual StreamYard thing.
How about now?
Oh, okay. Okay, now it's good. It's good. It's all good. It's all good. Sorry.
It's all good? Okay, sorry, I've taken my headphones off. So let me very quickly, was there a lot that you missed?
What was it?
Was I muted for a very long time?
Yeah.
Okay. So let me just finish off this demo very quickly. We're just going to do a quick delete. We're going to execute that. You can see that's now removed. So when we go into Snowflake, what you'll see, that record's gone. No longer 10 records. What you'll see in the query editor is something slightly different. So let's go ahead, rerun that. And you can see that record here, delete operation metadata op equals D. So what we've presented here in Iceberg is that we've done slowly changing dimensions type 2. So every record that we've inserted, any transaction that we've seen, we've inserted as a record downstream within the VNet. So that was just a recap of a quick review of the demo itself. Hopefully it's been beneficial. Now we'll just led up nicely to Q&As. So I'll stop sharing now and give it back to Dani.
All right, thank you so much. Yeah, that was an amazing demo, and I think at the end the sound was just an issue on the YouTube side of the stream. It probably kept working for the LinkedIn side, but anyway, yeah. So we had a few questions already, but everybody who's watching, if you have any questions, please ask them now, while I'll share the last slide that I wanted to while we go through these. Yeah, so yeah, I just want to put that out there in case anybody wants to reach out to us or look at the platform a bit more deeper. There's a free tier and the free trial as well for 30 days. So if you want to get up and started yourself, you can just go to estuary.dev and try it out. Now, as for the questions, so early in the beginning, somebody asked, Sandra asked if the app is available currently, and yes, it is definitely available. You can sign up, go to estuary.dev, and try it out for free. Brandon asked a question about their tables being locked in RDS, which I think Sean already answered, that you should reach out to our support. But also, I think that that's definitely not something that should happen. So we use a modified version of Netflix's dblog for the initial backfill that we execute on source databases. So if you use the CDC connector, there should be zero or close to zero amount of locking happening. So yeah, please reach out and we can take a look at what's happening there. Okay, let me go to the other comment section. Okay, so Zulf, I think this is a good one for you. How does Estuary deal with schema changes that happen on Postgres and apply it to both Snowflake and Iceberg?
Yeah, can you hear me now?
Yes. Yeah.
Yeah. Okay. Sorry, I've got my headphones back on. So yeah, as we pointed out within the UI for Capture, you saw that there was schema evolution, and by default that's enabled. So any changes that happens on the source will get propagated downstream. Now, if you want your materialization jobs to be in sync, there was an option in the materialization to say link with Capture. So if there's any new tables that's created, new collections will be created, and automatically those collections will be added as part of the materialization, as long as you have that link with Capture option enabled and schema evolution enabled by default. And that's how you'll sync your schemas from source to both your targets downstream.
Awesome. Cool. And the other question that we had, sorry, I just have to navigate to the YouTube interface, was from Jason asking, how do I monitor my pipelines and see if something goes wrong?
Yeah, that's a good question. So straight off the bat, within the UI, you've got the alert mechanism and you've got the logs that you can look into for troubleshooting. We also have monitoring API, open metrics API that you can use to integrate with your monitoring solutions. If you look at in our documentations, we've got examples using Datadog and Athena, but you can also use other monitoring solutions to hook that API into your own monitoring solution and put, again, alerting mechanisms on that. And there's, a plethora of metrics that you can use to actually start monitoring your pipelines. But this is also something that we're also going to be enhancing as new iterations of Estuary comes along. So watch our roadmap very closely.
Cool. And those were the only questions. Brandon, if we suppose Estuary, is it mandatory to have a Postgres or S3-like as it is decoupled?
So what was the question?
Sorry, I can show it. There we go.
If we self-host S3, is it mandatory to have Postgres or S3-like as it is decoupled? Self-host. So self-hosting, again, let me just clarify that for self-hosting. It's the private and bring your own cloud is still based on cloud architecture. So as long as you're using Azure, AWS, Google, we can deploy a data plane within that environment. That is kind of, I wouldn't describe that as self-hosted because that normally indicates on-premise. But yes, you can have your own private data planes in your cloud of choice and region of choice. Now, is it mandatory to have Postgres or S3-like? I'm not sure what that means, but hopefully you can clarify. But I'll just say you can have any number of sources, targets. The cloud storage is the only thing I'd mention that's different in there. So by default, it's using Estuary's storage in Google Cloud. But in there, we'd always recommend using your own storage. And again, that would preferably be on Azure, on AWS, or on Google itself. But yeah, if you can reiterate that question, maybe I didn't understand.
All right, cool. That was the last question. I can wait a few more seconds to see if anybody has anything else. If not, then thank you so much for joining. I hope y'all enjoyed this demo by Zulf. He walked through a lot of features of the platform and set up a lot of connectors, and everything seemed to work in the end. So amazing. Really happy to see that and how fast it all was. We will follow up with the recording in case you missed the first half or the beginning, or you want to forward it to someone else, and it will be available on our both on our LinkedIn and YouTube as well. So yeah, thank you so much, and have a nice Thanksgiving break. All right, bye-bye.